Hello, my name is Gabriel. I'm a senior Android developer and research and development team leader at Guru. And today I want to talk about offline first approach in applications. In the earlier presentation, was talking about how to set up the application, how to take care of the environment of the whole DevOps structure and setup. And I'm going to talk about more about building different approaches in mobile applications. But let's take a look for this on this picture. Does it sound and look familiar to you guys? Because for me, of course, yeah. And it's not something really weird. We are used to have internet connection in mobile phones. Our mobile carriers are offering us many gigs of data each month, and we have a Wi-Fi over home in in our workplace, in like transport. So we are used to have internet almost everywhere. But does it mean that we shouldn't care about how we are using it? Not really. I will tell you a really short story about how I started to wondering about those topics. Uh, Basically, our origin story of this presentation. So some time ago, I was a bit hurried to the office because there were some really important meetings taking place. So I jumped into the elevator, put my phone into the silent mode, and wrote very important message. I pressed send, jumped out of the elevator, and ran to the meeting. After like or so, I took my phone and I've noticed that there is something wrong. My message wasn't sent, and I started to wonder what happened. Why my phone wasn't able to resend this message once again when I was having the internet connection. And I went through some applications I had installed on my phone. I turned the flight mode on just to block every connection, like internet connection or data itself, and started using some applications. And guess what? Many of those weren't supported the offline, and I started to wonder why. We have like 21st century with autonomous car driving, and my phone is not able to resend the message. Yeah, you know the answer is that because those application was built on online first approach. And it's not a title of my presentation. Yes, that's exactly opposite title of my presentation. But first things first, and I want to talk about the most popular approaches for building mobile applications. I myself didn't like include some diagram, so there it is. In the really sophisticated diagram, you can see how it's all connected. The left is of course the application itself. The right is API, and our application is basically connecting between application and the API. So in the real world, our application is sending the request, something like give me data. We are receiving this. Okay, so let's display this. And if everything is fine, we're displaying the data for the user, and we have a very nice user experience. But imagine the situation which we have, which I have in the elevator. So imagine the API is gone. So basically, our internet connection is not responding. What's in this case? Of course, we can have like something, some mechanism that will display error message, and that's probably fine. But what should be done next? Should we repeat this this request? Should we present some kind of information to the user? Should we allow them to make like manual resend? You need to consider many things there. And yeah, unfortunately, most cases will be just showing the user that something went wrong because you basically don't even know what happened to your application. Yeah, so our application suddenly stops working and we don't know what happened, and our application behaves just like many of those in my phone, so we cannot use them. So just to sum up, what's the online first approach? It's uploading data directly, as you see on these connections. There weren't any connection to the there was only straight connection to the backend. There was no, or it is really rarely used, caching mechanism. We are fetching data on demand, and local storage is used only to save the most crucial data, like some kind of authorization token. And I want to be clear on that. It's not bad approach. It's not that I'm saying you guys need to stop writing the application in this way. I have a much better idea. No, no, because it really depends on the type of application you are building. Let's consider, for example, some stock exchange markets application, which heavily relies on most up-to-date data. Because, for instance, if you will buy some stock for the higher price than it is actually right now, who should cover this difference? There are many business cases which relies on the most data, and you basically need to be online to perform some actions. But if your application doesn't require you to do so, you probably should consider implementing the offline first approach. And yeah, that's the title of the presentation. What's the offline first approach? As you may notice, is the opposite of online first approach. So we are assuming that our user won't have a network while using our application. So we can achieve this. Let's imagine that in between this left and right block we have we are inserting the database. The database will be some kind of middleman. So each request and each response will be saved or will be gathered from the database, and basically we are good, right? And yeah, I probably hear your voices, right? Yeah, that's a lot of boilerplate code. Yeah, that's another the abstraction maintain. And yeah, of course, you will be right about it. Because you need to care about database, you need to care about this whole accesses to it, and you will need to care about it. But fortunately for there are many of libraries. For example, on the Android, you can use Room, which makes operations much easier on the database. You don't have to worry about the cursors, about content providers anymore. So this like learning curve and easy and level of abstraction needed to be implemented is way lower than even 2 years ago or so. So we shouldn't worry about it so much. We should implement this, but it's not only the database that matters. You really need to make the database as a single source of truth. And that means the database should be the only place where we pull or push the data, because everything we will have to send to the backend should be written to that, and everything that we will download from the internet will be saved to that. We have two bonus things for using that. Database much faster than network connection. So yeah, you are kind of able to receive data faster than from network, so you can get rid of almost all the power you have in your application. The second advantage is that database allows to persist data even if the app was closed. So no matter what the user will do, if he will close your application or or your application will crash, if he will reopen it, the data will be still there. So that's really nice, like bonus from that, and we can take advantage of it. And okay, so we have this database. We are pulling the data from the database and pushing the data to the database, but we don't have data in there, and we don't have basically anything to save this. And that's where the data pushing mechanism comes to action. So as I mentioned, this mechanism is responsible for basically downloading the data and saving into the database. And please consider and look at the very big advantage of having database. Now you can fetch the data independently from the user activity. You don't have to wait, for example, till the user will navigate to the profile screen to download the profile data, because you can do it asynchronously. You can do it periodically, and thanks to that, you can save again a lot of progress bars to your user. Because imagine the situation in which you have a pretty big application, any of data needs to be downloaded, processed, etc. On each screen, user will have to wait until data is downloaded from the backend. So why not to accumulate some of the most critical paths the user will visit in your application and download the crucial data under the, for example, the splash screen. So the first run of the application will take a bit longer. User will see the splash screen, but under it, we will download the data, save it to the database, and you will be able to present it to the user when he will reach the screen almost immediately. That's a huge improvement, and together with pulling data from the database, you can get rid of many progress bars, and even all of them if you will define your critical path very well. So we have the data in the database, and we have some kind of mechanism to this data, do it periodically, independently of user activity, or if you want to, you can do it on demand, like in the online first approach. But if we are going to download such amounts of data, such a big data sets, we will probably have really messy database. And you are right, and that's the job for synchronization. And I'm gonna be honest with you all, that's the most important and the hardest mechanism I will talk about. Even very big companies like Facebook, Airbnb, etc., have problem with this mechanism. If you want to see how big issue synchronization is, just turn off your internet connection, go to the messenger, scroll a bit, turn on your internet connection, and probably you will have your messages completely out of order. If you will gonna send some another message when you have some internet connection troubles, you will not be able to determine which of those message was sent earlier. For the other hand, Instagram is doing great job at data synchronization. You can post, like the pictures, you can navigate through many profiles, and only later on you will notice that something is wrong, because basically Instagram will show you the error because there is no more data for you to show cached, but they are doing a great job with that. How we should proceed with synchronization? In the easiest case, easiest scenario, you should probably upload all temporary entities to the remote server. So as I mentioned, single base as a database as a single source of truth should also have saved data you are planning to send to the backend, or who was sent but it wasn't successful. So we should probably mark them as kind of temporary entities. So in this data synchronization process, you will have to upload all these temporary entities to the remote server. And if you will receive the response from your server, you should update all entities in the database with newest remote response. And it might look easy, but believe me, it's not. For the simple cases like some really simple application with 2 screens, probably this algorithm I presented to you will be close enough. But in the bigger applications, probably it won't scale so well. You will have to figure out how, what, and why basically you need to synchronize. But I've got one pro tip for all of you wondering how you can proceed to that. You should update all entities in the database. Probably you should have your application almost copied a database as on the web server, on your backend server. Basically, because you want to have the same IDs, the same, let's say, I don't know, structure as your web server, because if you are going to update database with newest remote, you probably don't need to do some kind of mapping stuff or whatever. You probably need to believe that your ID match the ID you have in the remote server. So yeah, that's something you should really consider. The last thing, but not like mandatory one, is the cache mechanism. Having those blocks connected already will allow you to reduce internet connection. Basically, you can have some caching layers implemented. It will allow you to save bandwidth connection. It will allow you to give users even more immediately access to the data they need. Because, for example, you can introduce cache mechanism as in the local, in your application. That means you can store the most crucial data, which your user will probably need in the memory as the normal the normal variable, without any callbacks, without any, for example, error exchange. So your data can be fetched synchronously. So once again, way to get rid of progress bars. Also, we can implement the backend cache mechanism, but you will of course need to discuss this with your backend developers, and you will be able, thanks to that, save some resources. Because, for example, in the case we are downloading data periodically or hiding it under the splash screen, we can make agreement with the backend that you will see, and for example, date of your last update in the database. By that, backend can reduce your response to the data that actually changed in the meantime. It's worth to implement, but it's not like core mechanism of, let's say, offline first approach. It's just benefit that you can cheaply implement to that. Because you have all the pieces needed, basically. You have this database, which will handle the data saving, and you can really tell which data from which period of time you are using, and can explicitly ask backend about the data that actually changed. So to sum up, if we will have this all blocks integrated, how it will look like if our API will stop responding. Our application is requesting data from database, so probably from the user perspective, he won't be able to tell even that your internet connection is interrupted. Data will be collected from the database. That database is a single source of truth. Data fetching mechanism will guarantee us that in the database there is data to be displayed. Data synchronization will guarantee us that if something failed to be sent to the backend, it will be resent once the internet will be again accessible. Will reduce amount of data sent between the application and the API, and finally, user will be able to use your application in the offline mode. So as you see, connecting all the pieces together will result in robust, uninterrupted user experience when your internet connection is not as good as it is, for example, in your home office or whenever you are using Wi-Fi. So to sum up, you need to have database, a single source of truth, periodically or on-demand data fetching, data synchronizing, and optionally, but nice to have, cache mechanism. And I would really love to end this presentation. So that's everything you need to know, but that's not true. You will have to consider many things, like how do you need to fetch the data? Is for you business case okay to fetch it like once a day, twice a week, maybe once for a year? How you will manage data fetching process, as I mentioned. Will you do it periodically? Will you do it on demand? Do you need to upload content right away? You need to consider this. You need to wonder, do you need to upload right away? Because, for example, if it's liking the picture of your friend's dog on Facebook, you probably don't need to upload it as soon as possible. But if it's buying some product, then probably do you need to show the user that they are in the offline mode? Again, if it's on some kind of social media when liking the pictures, probably not. But if you are collaborating on the document, yes, that's a good idea to hey, you are in the offline, we will synchronize everything, your internet will be back. And do you need to inform the user about data sync process? So show some progress bar that we are downloading stuff. How you will support manual refresh data, like pull to refresh. Because basically, if you have some scheduled work to download data, how you will be handling this if user want to do it explicitly? Yeah, there are many things to consider, but I think I can guarantee you that it's considered to consider offline first capabilities in your application sooner than later, but it's good to consider later than never. And thank you so much for being with me. I'm gonna run some through questions if there are any. Okay. So yeah, I've got one question, as I see. A question is, if you only update data according to the response from API, how you handle data which was removed in API? Yeah, and that's the case. Probably there are of course, there are many ways to do that. But in the most recent project I was working on, we had this cache mechanism also on the backend side. Basically, we had a contract with the backend in which I was sending my last update date to the backend, and we had three different, let's say, objects in the response: added, removed, changed. If it will be added, then we will have all the list of added items in some kind of section since my last update in the database. So the whole object which I can save to the database. This deleted, which was the IDs of deleted items. So I received this list. I deleted my object in the root database, and if it was changed, that there were a list of objects that was actually changed. So it's the more complex case, as I mentioned, that you need to probably wonder if you are gonna to consider offline capabilities of your application, but it's doable. It's also all the call of the backend guys, because they like to decide on things. But if you are working on the application together, and if you are developing it together, it shouldn't be a problem to have some this kind of agreements. Okay, I'm gonna do more questions. Yeah, I don't think it should be. Sorry, it looks like I started from the bottom. Summary: use room to cache stuff. Yeah, basically that's the point of what Google is rooting for. Yeah, the splash screen, of course, was the example of how you can hide the process. If you have to download like 10 megabytes of data, yeah, probably you shouldn't do that. If you have something like Pavel is saying, you can hide this process under whatever you want. You can be on the other screen, download the itself. You can be on the splash screen, or maybe you want to use, for example, Work Manager to schedule your update at, I don't know, 11 o'clock each day. It can also work. So that only depends from you, from project, from the business case you want to solve. And yeah, of course, I just to be clear, I agree that we shouldn't hide many things under the splash screen, because it will result in pure user experience, because user basically need to wait for your app to load, which is poor. Okay, hopefully I miss any question. Yeah, so of course, if there will be any more questions regarding my presentation or work here in Netguru or so, we have this panel discussion taking place in 10 minutes. So yeah, let's see you then. Thanks.